Hey guys, welcome back to Learn Python the Hard Way. In this exercise 49, we are going to build on top of the lexicon parser that we built in the previous exercise, and we are actually going to create sentences. So in the previous exercise, we already created a lexicon, and based on that, we can basically pass some very simple sentences to our lexicon parser here. And this is going to scan whatever we provide, and it can basically classify the words that we provide. So as an example, if we just hop over to our terminal and we navigate to the directory where we actually created the parser, then we can enter the Python interpreter by typing in Python. And here we can first of all import our lexicon. And once we've done that, we can call lexicon.scan and then pass the input to it. And then based on the script that we wrote in the previous exercise 48, it will basically classify whatever we pass in here, provided it's actually part of our lexicon. So we need to make sure that the words that we have in here are actually part of our lexicon. And then it will basically create such a list of tuples and classify if, for example, the word here is a verb or a direction, and that will be stored in this case, this pair of two tuples here. And just to have a little bit of a more complex sentence, we could say, kill the princess, pass that to our lexicon scanner, and now we can see it classifies or identifies three different words: the verb kill, the stop word the, which we are going to ignore going forward, and the noun princess. Just one more example. If we pass in eat the bear, then of course again it will be classified as a verb, stop word the, and then the noun bear. So we can use that as a basis to actually create sentences. And that will then be the foundation which allows us to basically pass whatever sentence we like to a game, for instance, and then the game will be able to read the input we provide and, for example, perform an action accordingly. So in order to be able to actually pass a sentence and see if it's valid, let's just take a simple look at what a general sentence would look like. So what we're going to do going forward is we're going to create a separate sentence class. And the basic structure of a sentence, of course, is subject, verb, object. And of course, there can be edge cases, there can be very complex structures, which we are going to ignore for now. But that can be a very good starting point. So what we're going to do in order to create that sentence class so that we can see if a sentence is actually valid is the following. We are going to need 5 different tools that we're going to use. First of all, we need a way to loop through the list of scanned words, so that basically when we provide a sentence, we can scan the list of words there. So that's pretty easy. Then we need a way to match different types of tuples that we expect in our subject, verb, object configuration. We also need a way to peek at potential tuples so we can make some decisions. And we need also a way to skip over things that we don't really care about. Like, for example, the stop words we saw before, like the word the. We're going to skip over that and basically ignore that because it's not important to the meaning of the sentence that we want to analyze. And then finally, of course, once we scan whatever we provide, or we input, we need a sentence object to basically store the results in. And what we're going to do is we will be putting these functions in a module named exercise48.parser in a file named exercise48/parser.py in order to test it. So basically we are going to create a new project that we're going to work with, and then we can create the parser file in there to create our code. So in order to write the code to actually work with our sentence parser, let's just take a quick look at the basic grammar of the English language so that we know the basic structure we're looking at. So in our parser that we're going to write, we want to produce a sentence object, which has basically 3 different attributes. We're going to have a subject, a verb, and an object. And again, those will be attributes associated with our sentence class, so that ultimately we can create a sentence object and basically reference the subject in our sentence, the verb, or the object. So if we take a look at the subject attribute here, this is the subject of any sentence that we provide. Depending on the sentence, the subject may be implicit. So for instance, if we pass a simple sentence like go east, for example, to our sentence parser, then the subject is implicit. So basically, if we say go east, we basically are referring to our player. So we basically say player go east. So in the case that we have something like go east, or for example, run north, then we basically imply that the subject is the player. And this will be, of course, a noun. Next, we have the verb. So after the subject, we have the verb, and that is basically the action of the sentence. So in the example run north, where again the subject is implicit and refers to the player, run would be the verb, of course, that will be stored as an attribute in the sentence class as well. And finally, we have the object attribute here. So that's another noun that refers to what the verb is done on. So in our game and in the previous exercise, if you think back, we had, aside from nouns, we had another type of words referring to, which is basically the direction. And those would also be objects. So we have nouns and we have directions to choose from. So in our sentence run north, north would basically be the object in here. And if we had hit bear, then bear would be the object. And of course, bear would be classified as a noun and north as a direction. So it can be either a direction or a noun. So our parser then will basically has to use the function that we describe, and provided we pass a sentence to it, it should convert it into a list of sentence objects which match that input. Now, one important point to mention here is our exceptions. So of course, there can be cases where we pass in some invalid input, for example, a sentence that doesn't make sense grammatically. And in order to deal with that, we are going to create a parser error object here at the top. And this class is basically going to use to raise any exceptions. And in our tests that we are going to write, we will also work with these exceptions and take a look at that. So let's take a look at how we can create the code. If you want an extra challenge, then just based on the description, you can try to write your own code. If you prefer to follow along, just take a look at that. And the main objective of this exercise is actually to write the tests, not to write the code itself. So what we're going to do, first of all, is we are going to create a parser error class, which inherits from exceptions. And so all the errors defined in the exception class will be available to us in the parser error subclass here. Next, we're going then to create a class called sentence. And first of all, as stated before, we are going to store the subject, verb, and object in our sentence object that we're going to create from the sentence class here. So we need an init method to actually store the subject, verb, and object in our object that we're ultimately going to create from the class. So what we do here is we reference self, of course, and then we want to store the subject, the verb, and the object. And if you think back in the example we saw before, if I just scroll up here a bit, we always have those kind of tuples that we pass in. So here, for example, we have verb go. That would be one of the tuples. And since we are interested in the verb itself, for instance, here, and we want to store that, we actually need to reference our tuple, and we are going to take the second entry here so that basically means that we are going to refer to position 1. So here, not position 0, which would be the word type. We're going to refer to position 1, and that's going to be stored in our sentence class. That's the reason why, if we take another look at our code here, we are actually storing subject 1. So we are taking our tuple and we are going to store not the first entry here, but the second one, and that will be stored in our subject attribute here, and the same for the verb and the object. So in order to properly scan our input that we get, we need a couple of different functions that we can work through. We're going to need a peek method here, which is taking a word list that we provide, and this is going to check that word list and basically returns what type of word it is. And that's going to be useful later on if we want to determine if our sentence is grammatically correct. So if we have subject, verb, object, and for example not subject, verb, verb, which would be invalid. So that is required. Next, we are going to need a match function or method here, which basically confirms that the expected verb is the right type, takes it then off the list and returns the word. So here in our match function, we're going to take the word list and what we are expecting in terms of the type. And if the word list actually exists, is not empty, then we're going to pop off the first entry here, basically the first tuple, which we're going to store in Word. And if the type of the word, which again, if you think back of the tuple, is again the first entry in our tuple, if that matches the expecting type, so for example type verb, then we are going to return that word, which is again the tuple. Else, if that's not the case, we are going to return none. So that's basically what the match function is going to do. And that is all going to make sense in a second when we take a look at the entire program. So finally, what we need to do is we need to make sure that we can skip over words that we don't need, that we're not interested in. So we have those stop words, which we classified as stop in our tuples. They are not relevant for the meaning of our sentence, so we are completely going to ignore those and basically skip over them. So stop words would be words like the, and a, and we're completely going to ignore those, so we have to just skip over them. And here we are going to use, inside of the skip method, we are going to use the peek function that we defined before, and we're going to check if the peek, what we are looking at, is equal to the word type, and then we're going to call the match function. We're going to take a closer look, but that basically helps us skip over all the words that are stop words, and we're just going to take a look at the words we're interested in, meaning nouns, verbs, and directions. And skip, because we have a while loop in here, doesn't skip just one word, but it skips as many words of the type that it finds. So, for example, if we have scream at the bear, we have two stop words here, at and the, and we are going to skip both of those. We are just going to get back scream, which is a verb, and then bear, which is a noun. So that's basically the foundation that we are going to use in parsing our functions. And we can use that to parse any text that we basically want. So the remaining functions are just going to use those different functions we define, the peek, match, and skip function. And then we can take a look at parsing the verb, parsing the subject, and parsing an object. So let's start with parsing a verb. Again, we're going to take the word list that we input in here. We are going to skip any stop words, since we're not interested in those. And if the verb or the word that we're looking at in the word list is actually a verb, for example, scream, then we're going to return this back to us because we want to parse the verb. If that's not the case, we're going to raise an error because we expect a verb next. And that's going to make sense when we take a look at the sentence class that we're going to return, because there we want to make sure that we always follow that structure subject verb object. So if we would actually expect a verb, then we should get that back. If that's not the case, our sentence is grammatically not correct, and then we would raise an error using the parser error class we defined at the top of our file. In a similar way, we need a parse object function here. Again, we're going to skip the stop words because we're not interested in them. We are then going to use the peek function again to take a look at the word list and identify the next word. If the next word is actually a noun, then we are going to call the match function here and basically return that word back to us. If the next word is a direction, again, it's important to mention we have nouns and directions. Both are valid objects. So in either case, we would be okay with that. We are calling the match function to return the noun back to us or the direction. Both are okay. But if it's neither a noun nor a direction, so basically if it's a verb, then we're going to raise an error again. And the error message basically is that we expected a noun or a direction next for a valid sentence. And finally, we want to pass our subject, of course, of the sentence. Again, we skip the stop words. We're taking a look at the next word. And if the next word here is a noun, we are returning that back. If the next word is a verb, which basically means because we start our sentence with a subject, of course. So if the first word in our sentence is a verb, then the subject is basically implicit. So if you think back about the case of, for example, run north, the example we had before, if we have such a sentence, run north, that would still be a valid sentence. But here we have a verb first, so the run verb, and therefore the noun is implicit. So in run north, the noun would be the player, so the sentence would basically be player run north. That's why we need to check if we have a verb here. So either a noun or a verb would be valid. In the case of a noun, we would actually return the noun back. If we have a verb, then the noun would be the player, the default implicit noun. And if you have anything else, any other type, so basically an object here, then we would raise a parser error. So with all of that defined, we have just one final function, which is the parse sentence function. So this is also basically the starting point of our program. Here we are going to take in the word list. And again, we have the subject, the verb, and the object. And we're going to call parse subject, parse verb, and parse object. We're going to take a look at that soon, but basically whenever we call any of those functions, what we do is we basically pop off the word. So when we call parse subject, we are going to basically get back the subject of our class, or the implicit subject in the case that we start with a verb. And then we're going to pop off that particular tuple, so it's no longer there. So once we have the subject, we switch over, take a look at the remaining tuples that we have. We get our verb back, we pop that off, and then we take a look at the object. That's basically how we can construct our sentence. And those three attributes here that we basically assign to subject, verb, object, we are then going to assign to the sentence class. And that means we ultimately return back the sentence class here, or sentence object, with the subject, verb, and object passed to it. So that means we can store the return here in an object, and then we can simply use that object to refer to the subject, to the verb, and the object. And again, that's going to get a lot clearer when we take a look at the entire program. So let's do that. If you haven't done that yet, you can switch over to your terminal and just go back to your projects list. And here you should have your skeleton project that we created a couple of exercises ago. And then of course you can go ahead and recursively copy that skeleton project over, or better yet, I would recommend to copy over that exercise 48 folder directory here that we created in the previous exercise, because we already defined the lexicon scanner in there. And then we can just create a new folder here. So for example, I call that exercise 48 done, for instance, and we can copy that over and build on top of that. Or of course you could simply add that to the existing directory, the existing folder that you created in the previous exercise. So if we hop over to that folder, again, you should have the exercise 48 folder here. And if you take a look at that, we have our lexicon.py, our code file here that we created in the previous exercise. And we are now going to create a new file called parser.py, so our parser file that we're working with. I'm going to use Visual Studio Code, so I'm going to type in code followed by the name. I already created that file ahead of time, but if I open that, I'm basically going to get this file back, which includes all the different aspects we just talked about. And let's just take a moment to take a look at the overall structure. So here at the very top, we have our parser error, which again inherits from the exception class here, which gives us access to the different errors that we're going to work with. Then we have the sentence class here on top, and below that we have the different functions we're going to use. And to properly understand that, let's actually go to the very end. So what we're going to have here is basically our parse sentence function at the very bottom. And that's going to take in a word list that we provide. That word list is going to be a list of tuples. And again, we can get that by using our scan method that we defined in our lexicon.py file. So that allows us to basically take an input and then turn that sentence into a list of tuples. That list of tuples here is then basically the starting point for our parser. So we're going to take a look, and first of all, we're going to take our list of tuples, and we're going to, first of all, use parse subject. So just to make that a little bit clearer, and we're going to type that in soon, this is basically what we would provide. So we would type in parse sentence, and then we have a list of tuples. So here, for example, a verb, run, and a direction north. That's basically the word list we enter in here. In this case here, we start with a verb, so we don't have a separate subject, or the subject would be implicit, but let's take a look at what would actually happen. So we have parse subject, we pass the word list to it. The first thing we're going to do is we're going to skip any stop words. So in this case, we don't have a stop word, but if we did, we would go over to our skip class up here, and our not the skip class, the skip method actually takes in a word list, or we pass the word list to it, and then we pass as a second argument here the word type that we want to ignore. So in general, we want to ignore the stop word type. So here we are checking while our word list, and we're going to take a look at the peek function soon, while that is equal to the word type, then we're going to call our match function and basically return the word type from our word list. So let's take a look at the peek function, which is up here, and again that takes our word list here that we pass in. So if our word list is not empty, then we are going to store the first tuple, so in our case verb run, in Word, and we are going to return back the first entry of the tuple. So here in this case it would be the verb. So that would be returned back from the peek function. So here basically we have the verb, and we are checking if that's equal to the word type. When we called the skip function here, we passed the stop word to it. So the verb is actually not equal to type stop. So basically the skip function would basically not execute the next line here. We would basically not return anything from the skip method here. But if it was a stop word, so if we started our sentence with the, for example, or any other stop word, then we would hop over to the next line and call match. And match again takes the word list and the word type. So the word type, of course, would then be a stop word, and we have the list of the word list again. So here in the match function, we basically take a look at the word list again and we pop off the first tuple. So in our case, it would be verb run. Of course, it's not going to be executed because it's not a stop word, but the first stop word would basically be popped off. And then again, we take a look at the first entry here, so the type, which would be stop in that case, or in our case here verb, and we check if that's equal to the expecting type. So here we pass in the word type, of course, which is equal to expecting. So we check if that is equal to that, and then we would return that back. So in our case, if that would be a stop word, then we would return back that tuple here, which then goes back here to match, and that would be returned here from the skip function. So we would basically go back to skip here, and due to that, since we called pop over here, the stop word would basically be removed from our list. So that's quite useful for us, because then we skipped all the stop words in the beginning, and we basically just have the other words remaining in there. And that works because we have a while loop here, so we're going to skip over all the stop words. So next we are going to call peek again, and now we start with the other tuples which are not the stop word basically. So we take a look at peek again up here, and we check if we have a value in the word list, and then we take the first entry here, so the type, store that, and then return that back. So we check the first tuple here and the first entry of the first tuple and return that back. So in our case, that would be the verb here. Now we check if the next word here that we stored in here, if that is a noun. In that case, we would return back that noun. In our example here, it's not a noun, it's actually a verb, which is the next statement we check, this elif. Oh, I'm sorry, actually, I skipped the line. We are down here. So we check if it's a noun, which is not the case. Then we are checking if it's a verb, which is the case here. In this case, our noun is basically implicit. So we return back noun player, this tuple here. If we have neither a noun nor a verb, so basically if we start with something else, then we would raise an error here, so that we expected a verb next. So that is pass subject here, so we return back, in our case, noun player, which is stored in the subject variable here. After that, we are going to take a look at the verb, and we are calling parse verb. Again, this takes the word list in, and just to think back, we popped off the words that we already basically analyzed here, because if we took a look back up here, we call that match function, and that actually pops off the first entry, or the first tuple from our list. So verb run, this tuple is already popped off. So now when we take a look at parse verb, we can skip any stop words that we have, which we don't have in our case, and then we take a look using the peek method if we have a verb next. So in our case, we are going to take a look at that list. We have now verb run, and since we didn't have a noun in the beginning, we actually didn't call the match function, didn't pop off any entries, so we have verb run. That is checking the peek. We actually have a verb here, so we are going to call match. And again, that would basically mean we pop off the first entry from the list, so verb run. We check if that is actually equal to what we expect. So we're expecting a verb, which is the case here. So we're going to return our tuple. And then this is returned from the match function here. We are returning that back. So basically our tuple here would be stored in the verb. And now our tuple is basically, it has a length of 1. So we only have direction north remaining. So finally we take this last call, parse object. Here we skip all the stop words if there are any. We call peek again to identify the next word. which would be direction north in our case. That is stored in the next word variable. We check if that's a noun, which is not the case, so we skip over to the elif statement here. We check if it's a direction. That's indeed the case. So now we call match again up here. And in the match function, of course, we're going to pop off the first entry, which is basically the only one remaining in our list. So now we have basically an empty list at this point, and we're going to return back that tuple. So that's going to be returned from the match function. It's going to be returned from parse object, and that's going to be assigned to our object variable here. And then finally, at the very end, we are going to return our sentence class here, passing subject, verb, and object as an attribute to our sentence class. And if we take a look at the very top here, of course here we are setting the subject, the verb, and the object attribute inside, or the parameter inside of our sentence class. And here we are interested only in the first position, so in the second entry of our tuple. So the subject was implicitly basically player, then we have the verb run and the direction north. And that's the reason why if we call x, which is the object created from our sentence class, x.subject we get back player, x.verb we get back run, and x.object we get back north. So that's the basic structure. And now if we just double check that, we can hop over to our Python interpreter. We of course need to import from our parser. Let me see if I'm in the right. Oh, I think I'm not in the right. Yeah. So we have to make sure that we are in the root folder here. So if you type in ls, we need to make sure that we have basically our folder structure here. And then if we go into the Python interpreter, we should be able to import from our exercise 48 directory the parser file. We're going to import everything. And now we can use parse sentence and pass in the list of tuples. So we have a verb first of all, which is run. Then we have direction north, like this. And now we have basically here our sentence object. So if we type in x, we can see we have a sentence object here. And to reference the different attributes, we can simply call x.subject, which is player, x.verb, which is run, and x.object, which is north. So we have a valid sentence here, and we have subject, verb, and object stored in our sentence objects, in this case constructed from the sentence class. So if we just take another example, which is a little bit more complex, we can say we now call parse sentence again. And this time we're going to have an explicit noun. So that means we don't start with a verb as we did in here, up here. Instead, we are going to start with noun bear. Then we pass a verb to it. Now we're going to have a stop word, which of course we are going to ignore. And finally, we have the noun honey. All right, so what's going to be the subject? This is going to be bear. So this time we don't have player as a subject because we have an explicit noun here at the beginning. What is the verb is eat. The stop word will be ignored. So the object should be honey. And that's indeed the case. And then of course, instead of basically passing in the sentence, the tuples here, we should be able, using our lexicon scan class, to actually pass in a sentence by itself, and then this can basically be parsed and then be executed there. So let me actually see if we can give an example of that. If we take, I think it was called lexicon. So if we say everything, then we take our lexicon, and now let's just do that in one step. So we have basically parse sentence. And here we are just going to call the scan function, scan method, and we are going to type in bear eat the honey. And now since we added honey to our list, it should actually work. And so if we take a look at that, we can call subject on it, verb on it, and object on it. And so in this case, we basically did everything in one step. We called the scan function here. We passed in this sentence that gave us back a list of tuples. Which we can see if we basically type that out here. So scan bear eat the honey. We get back this list of tuples, and that's the input to our parse sentence, where we store that in our object here, and then we can reference the subject, verb, and object. So that's basically how that works, and that's very handy because now we have our sentence object and we can very easily reference the different parts of it, so the subject, verb, and object. All right, so this is a code that we wrote. Now, in the next step, we should make sure that we actually test this properly so that everything is working correctly. And here we're going to learn about a new function that we're going to use inside of, as part of nose. So far, we used assert equals most of the time to check if a statement is actually, two statements are actually the same. So we checked if the output of a test was actually what we expected. But now we're going to learn about assert raises. So this way we can also test for errors, because if we take a look at our code here, parser.py, we can see that in some instances we actually raised a parser error here. And of course we want to check that this error is actually being raised. So this is why we need assert raises. In terms of where to create those tests, if we take a look at our folder structure again, of course we would create that inside of the tests directory. So here we already have our lexicon tests from the previous exercise. Next to that we can create our parser test.py, which is of course where we want to create the test specific to this other file. So if we take a look at those tests, we want, of course, first of all, make sure that we actually import nose, specifically the tools inside of nose, so that we can actually run our tests. And then we definitely need our parser file here. So we could either say that we want to import from the folder exercise 48 the parser file, the parser module here, and then we can call the functions here. In this case, I imported everything. The difference is that if you import everything, you can directly refer to those methods defined inside of that file, for example, peek. If instead you said from exercise 48 import parser, then we would always make sure that we reference the module. So in this case, it would be parser.peek. All right, we also import the lexicon module, which allows us to call lexicon.scan, to basically just pass in a sentence and then run it through lexicon scan to make sure that we get back our list of tuples. And now we want to make sure that we actually test our different functions that we have in here, starting with the first one, test peek. So if we take another look at that, outside of our sentence class here, that's the first function we defined. So here in peek, what we do basically is we take a look at the word list. We take a look specifically as the first tuple and return back the first entry of the first tuple, which is basically the word type. So to test that, we can say we have a word, for example, bear. We can then use lexicon scan to scan for that word. Of course, alternatively, we could also directly store that in a tuple. So we would create a tuple called noun bear. But we can use the lexicon scan approach here, scan method, to actually let the program do that for us. We call a peek on what we get back here, which is the tuple. and then peak will be stored in the word type. So what we expect, of course, is that we get back the noun, because it's basically the tuple noun bear, and this is what we are checking for here. Using assert equal, we are checking that this is actually a noun that is stored in here. We can also test that with multiple words. So here we have a words string with 3 separate words. Using lexicon.scan, we get back 3 different tuples. Again, it's important when you create those tests to make sure that these words that we have in here, that they are actually included in our lexicon, because otherwise, of course, the program doesn't know what to do with that. Now, once we have those 3 tuples, we can again call peek on it. And since our peek method here is going to take a look at the first tuple, actually doesn't matter what the second and third word is. We store just the first word type of the first tuple in word type here, and we check again that this is type noun, and again we are using assert equal. So that is how we can test test peek. Of course, there are different ways to test that. That's just one possible approach. After testing our peek function here, we can take a look at the next one, which is the match function here just below. Just to recap, here we take a word list and the expecting type. So for example, if we want to check if it's actually a verb that we get back, then we would pass verb as the second argument in here as a parameter to this function, as an argument to this function. So now if word list is not empty, we're gonna pop off the first tuple here, and then we check if the first entry of the first tuple, so the word type, is equal to the expecting type, so for example type verb. If that's the case, we are going to return that tuple back. So taking a look at our test function here, test match, you can see that typically we just write test underscore followed by the name of the function or the method, so it's very easy to map it to our actual code here. So here we have a word bear. Again, we're using lexicon scan. Again, you could skip that step and just directly store the tuple in a variable. So we would store the tuple noun comma bear in there, and then we are using our assert equal function here to check that bear is actually equal to matching lexicon scan, which is the tuple we get back, to the noun. And when we get back match, of course that's going to return the tuple, so we don't need the entire tuple here, but we're going to take a look at the second entry, which is then the name. That's why we're having that bracket notation here with the 1, so that should be equal to bear. We're checking if that's equal, and if it is, that would return true here. We're also checking if we get back none, if we basically using the match function here, and we're not indexing into the first entry. Again, we can do basically the same with multiple words. It's basically the same approach here, so we can check for that. And in a similar way, we are testing the skip method here. So we need to make sure that we have a word here, for example, bear. We have then the tuple here and the verb, and we want to make sure that we actually are skipping this. So here what we do is we assert the length of our tuple here that is equal to 1, because in this case we would basically skip one entry, and instead if we have we have the word here, and if we take a look at the second case here, we are actually skipping and taking a look when we get to a noun. Since we have a noun here, bear, we basically don't skip anything, so we have a length of 0. If you have something else, a verb for example, then we would skip that, of course, so we have a value of 1. Then of course we can take a look at testing our parse subject, parse verb, and parse object function here. So again, we parse subject in here, parsing, for example, the tuple noun mountain in here. So that's an alternative approach. Instead of using lexicon.scan, we can directly parse a tuple to it. If we pass in noun mountain, then of course we would expect that we get that tuple back. If instead we pass in not a subject but the verb, Then if we think back, we have the case that we implicitly expect the noun player to get back. So here if we pass in a verb, then we should get back the noun player. And finally, now we're taking a look at assert raises. So here, in terms of the structure, we have basically 3 different arguments. We want to have a parser error basically. Then we write the function name here, so parse subject. And as the third argument, we are basically going to pass in the argument we provide. So in this case here, that's going to be a list of just one tuple. So we pass in direction south into our parse subject, and we expect basically an error back. And the reason for that is, of course, that for the subject, parse subject, if we take a look at that just one more time, we basically check if it's either a noun or a verb. If it's anything else, for example, the direction as we have in here, then we would raise our parser error because we're expecting basically a verb next. So that's why here, when we pass in the tuple with type direction, then we should get back a parser error. And parse verb and parse object basically have a very similar structure. Again, we calling parse verb and expect the same back. And if we pass in a noun here, for instance, we would expect to get an error back. And in a similar way, we can have parse object here and parse sentence, which is basically combining parse subject, parse verb, and parse object. So here we pass in verb, stop, and then noun. And in this case here, we are asserting this equal. So passing the sentence should be equal to the sentence, basically noun player, verb verb, noun noun. So basically what we have up here. And importantly, we are if we use the print statement here to basically compare the output, because if we didn't do that, we would basically compare 2 objects to each other, and 2 objects, even though if they have the same attributes, would not be equal to each other. So in this case, we would get an error that would be unexpected. So if we use print, we can avoid that. And finally, we have a couple of parsing errors that we are checking here, which is quite similar to what we have up here. So once we have those in place, we can go up to our root structure, and ideally, of course, we would write those test cases in parallel to writing our code, so that whenever we write a new function, we also add our tests in here and can always check if it's working properly. So now we can run nose tests. In this case, we are running 14 tests in a fairly short time, and we can see status okay. So this is what we expect. Of course, if we change something here, we would run into an error. So let me just change this here to, for example, nouns. In this case here, we would see we actually have an assertion error. We expected noun, we got back nouns, which is of course because we made a typo here. So this way we can always check if we made an error in our code and can adjust that accordingly. So that's the main exercise here, the main part of the exercise. There are actually a couple of study drills that we can take a look at. And maybe let's just briefly focus on the first one here. So what we could do in terms of our structure that we have here, instead of basically having one class, a sentence class, and then the different methods below, we can of course change the design of our code. What we could do, for example, is that we take those parse methods. So that means parse verb, parse object, parse subject, and put them into a class rather than to use them just as methods. And which design do we prefer? So if we take a look at that, actually I just copied that over that entire folder and created a separate one called exercise 48 class. If we take a look at that and let's open that file, it should be in here. So again, we would take the parser file, but in this case, that's just a little difference. We have again our sentence class here on top, but now we have a separate class, for example, called parser. And inside of that, we have now the different methods like parse verb, parse object, parse subject. We need to make sure that we add the parameter self in there as well, because we are now inside of the class. We have that structured maybe a little bit nicer because it's inside the parser class, but that also means that we have to call those methods a little different. So if we again switch over to the Python interpreter and we say that from our exercise 48 parser we are going to import everything. Now we can, if we try to call parse sentence and we pass in, let's just use a very simple example, for example, verb go. Like this, go north. And now we can see that we get an error back. Parse sentence is not defined, and that's of course because now we are basically inside of a class. So that means we have to instantiate our class here. So we could say, instead of parse sentence, if we do parser.parse sentence, let me just take a look. So what we should be able to do, let's just use object parser. So I'm first of all going to instantiate our object based on the parser class. And now if we take our object and we say parse sentence, go north, like this. We can now call this again, but so if you take a look at the subject, that should now be player again because it's implicit. Verb should be go and object should be north. So again, we get the same output, but what we need to do, of course, we need to instantiate the object first, and then we can call those methods on it. So benefit here, maybe we have structured a bit nicer because we have the separate parser class, especially if we maybe want to use that in some other context. We have a little bit of nicer encapsulation going on. The downside is, of course, that we need to make sure that we instantiate the object before we can actually call any methods on that. So that would be an alternative approach that we could take. All right, the other study rule questions are actually just refinements to our program, so we could make the parser more error resistant to avoid annoying the user. We can improve the grammar. For example, we could add other word types to it, like numbers, for example, and deal with that. And then we could also use, of course, our sentence class in our game to basically pass a sentence to it, and then split out the subject, the verb, and the object, and use that for some cases. So again, we would basically, if we just do this here again, the way we would use that is we would combine our parser class with basically our lexicon.scan. I didn't import that, so that would give me an error, but what we could do is something like this that we saw initially. We can simply pass in the sentence here that would be stored in the tuples, the list of tuples, and then that could be stored in our object, and we can refer to the subject, verb, and object. And that's of course very handy to use if we have a text-based adventure game, for example, and we want to allow users to pass some sentences to it. So finally, let's take a look at one common student question here. The question or the issue is that they can't seem to get assert raises to work right. So again, if we take a look at our test cases here, assert raises is what we used to check for errors. So here we passed in the error type, then the particular method call, and then as a third argument we passed in actually the argument we want to provide. So in this case, a list of tuples. So we need to make sure that we are writing assert raises exception, the first argument, then callable, and then parameters, so just what we saw before, and that we don't write assert raises exception, callable, and then directly the parameters, and that it needs to be a separate argument that we provide. Notice how the second form is calling the function. We have that in parentheses here. When then passing the result to assert raises, which is wrong. You have to pass a function to call and its argument to assert raises. So we need 3 different arguments that we pass in here, and we need to have the parameters here as the third argument to assert raises. So assert raises is quite useful. We can use it going forward for our test cases in addition to assert equals. So that's it for exercise 49, and see you guys in the next exercise when we're actually going to create our own website.